Good morning, everybody. So today we're going to work through the second part of the study guide. This is to prepare us for this test that we have tomorrow and Thursday. Um, if you're able to do well on both these study guides and you're comfortable with just about every question on them, you should be just fine for the test. So please take this video as a chance to go through. And really work through any questions that you got wrong and understand why. Make sure you look through past assignments, practice IXLs. Don't worry about your score. I can see what your score was, so if it goes down, it's not a big deal. You're allowed to use notes for the test, so I suggest taking them on this video in the study guide. But again, this video could be pretty long, so if you understand the topic really well, feel free to skip ahead a little. It's okay. So let's get started. I guess one more thing. We will be doing a live stream tomorrow at 11, where I'll answer some questions, not exactly on the test, but related to it if you have them. And I'll also be posting a video that gives instructions on what you should do, so everybody shouldn't be too confused. So let's get started here. These first few questions should seem familiar. They were very similar to another Google form I gave you a few weeks ago. So this is an exponential function here, right? When x is in the exponent, we call that an exponential. For the following equation, what is y when x is 4? So what you need to do is you plug in 4 for x, and that'll give you y. Now remember, you want to be really careful with these. It's easy to make a mistake, as you have seen in the classroom. Right, we've worked with these all year. Exponents, right? So 2 times 2, 2 squared, would be 4. So if we times by 2 again, 2 times 2 times 2, 2 cubed, would be 8. So 2 to the 4th, we do that one more time, multiply 8 times 2. It tells us the whole thing must be 16. So you should have gotten 16 for your answer. Yeah, so let's continue. Let me just double check that real quick. Okay, so that's what I was kind of pausing here. Sorry, that was a mistake. This should be 16. So I'm sorry if you did this and I confused anybody. It's been a very busy week, so I'm sorry. Can't believe I just caught that on the first question. So, but that's part of the reason I wanted to make a video too, to make sure you go through and there's not little mistakes like that. So let's look through the next one for the following function. What is y when x is 0? This is just like one that we had on that Google form that people did really, that people struggled on for this question. So remember, anything to the 0 power. So that's what we're doing here. We're plugging in 0 for x. Anything to the 0 power is 1. So it doesn't matter what's inside of here. This is equal to 1. And then we have plus 1. So that's another thing. A lot of you, I think, put 1 as an answer. But remember, it's 1 plus 1. Right, because this was 1 here. Plus 1. So y is equal to 2. Okay, so that's what you should have gotten. Does the graph below show exponential growth, exponential decay, or neither? So remember, exponential growth, we'll use red for that. Exponential growth looks like something like this. exponential decay, like something like you see in the graph, there we go. And then neither, that could be a lot of different things. Neither would be something like a quadratic. It's not a good one. Quadratics look something like this. They look like those U's. Absolute value graph. That looks like a V. So also something you haven't really seen yet, but you will see later in high school. Sine graph. These would not be exponentials. These both are exponentials, but exponential decay is decreasing, right? Going down. Decay, decrease. Growth, getting bigger, growing. So this is decay because it's getting smaller, right? It's going down. Now, there's a little more to exponential growth and decay than, decreasing, increasing, but in general, for the test, this is what you need to know. For the following function, what is y when x is 2? So you go ahead and you just plug in 2 for x. Y is equal to 2, and x is 2, so 2 squared minus 4. Y is equal to 2 squared is 4, minus 4, 0. Okay, is the graph below an example of a linear function, exponential function, or neither? So this would be neither. I didn't mention linear function in that other example, but we talked about those quite a bit. Linear functions are straight lines. This is like a u, so it's not an exponential. This is actually called a quadratic. This type of graph is called a parabola. So this is a quadratic function that creates a parabola. This is something you'll work quite a bit with in 9th grade, probably 10th grade too. And you'll still, well, you're going to use it in high school, but you're going to probably learn most about it in 9th and 10th grade. And actually, functions like these are, I know you're learning about physics and science, these type of functions are incredibly useful in physics, especially with gravity. Okay, so what relationship does the let me actually, table below show for x and y? So what you should see for this, probably on the test, I'll probably take that out, but you see that this is going up by 5 each time. Remember how we started off in the air, right? We started off talking about linear functions. These always increase by the same amount or decrease by the same amount each time. Exponentials, you'll see the same thing, but you're going to multiply by the same number each time. When you add or subtract by the same number each time in the table, then that's linear. So that means that you have a constant slope, constant change. All right, expand the following. So this is a distributive property question. Remember with this is just kind of just some steps you're going to have to memorize. First, we need to do 3 times x. Then we're going to do 3 times 2. We're going to add up those products together. So this is going to be equal to 3 times x. Well, 3 times x is just 3x. plus, and we still have that plus sign, and then we're doing 3 times 2. 3 times 2 is 6. So you get 3x plus 6. Okay, so let's continue. Expand the following, so another question just like this. Throw in a negative though, and there's a y. Doesn't change anything. So first let's do negative 2 times 2, and then we'll do negative 2 times y. So negative 2 times 2x, maybe I'll write this one out this time. So we're multiplying these together, plus negative 2 times y. And now from here, negative 2 times 2, well, that's negative 4x. And then we have negative 2 times y, well, that's negative 2y. So instead of a negative, I'm just going to do minus 2y. Now, x and y, these are different variables, different letters, right? So that means that we can't combine these together. So our final answer is this. These are different terms. This would be like apples and pancakes. You're not going to subtract pancakes from apples. It doesn't make any sense. You can only subtract apples from apples. These are two different things, so you have to keep them separate. Expand the following. So another distributive property. This one, this is something that high schoolers constantly make mistakes with, so if you learn it now, that'll help you. So we have a negative outside the parentheses like this. So whenever you have a negative outside, you can always think of that as, okay, we have a negative 1 times negative x minus 2. So now we can distribute this negative 1 through, multiply that by negative x, and then we'll multiply the negative 1 times negative 2. So this is going to give us negative 1 times negative x. Well, you have two negatives, so they cancel each other out. 1 times anything is just itself, so this is really just going to leave us with an x. All this negative 1 is doing is just changing the sign of x, and you're going to see that it's just going to change the sign of negative 2 to its opposite. Negative 1 times negative 2 is positive 2. So this is going to give us x plus, let's do green, 2. I guess it should be red, because we did negative 1 times negative x with the red arrow, and then with the green arrow we had negative 1 times negative 2. That gave us 2. Okay, so now we have a simplifying problem, combining like terms, another very important skill. So first off, you want to look at your expression and think about what terms do I even have? Well, the only term, well, we have 1, 2, 3, 4 terms, and they're all alike because they all have the same variable x in it. That's in common for everything. Excuse me. So what we can do is we can just add up the different coefficients. Since these all have an x, we can just add up the blue coefficients. Alright, we said these all have an x, so we're allowed to do this. If there's a y in it, then, well, then we'd have another term we gotta throw in, but we don't. So these are all like terms. So this means that we're going to do 3 plus 2 plus 5 minus 2, and all this, whatever that is, times x. The 3 plus 2 is 5, plus another 5 is 10, minus 2 is 8. So this gives us 8x. Alright, next question here. Same type of question. So again, these all have this x. So that means they're all like terms. Right? They're all dependent on the same variable. So what we can do is just add up the coefficients again. Negative 3 plus 2 plus 4. And then I know we just see a minus, but remember that's a minus 1. And all this times x. So negative 3 plus 2 is negative 1. Plus 4 is positive 3. Minus 1 is 2. So this will give us 2x. Okay, another problem like this, but now this one has x and y. So we have x is one of our terms, or one of our variables, y is one of our variables. And so we have our x's, and then we have our y's. Okay, so now I'm going to actually take the coefficient with it this time. So this will give us over here, we're going to have 3x plus x, right, the pink highlighted terms. This gives us 4x. And then with the y's, the purple, we have 2y's, minus a y, and that gives us a y. So our answer is, we put these together, 4x plus y. And now we can combine everything together, we simplified it, and we keep them separate because x might be, this could be potatoes and this could be Mr. Stiley's, right? It doesn't really make sense to add up potatoes to Mr. Stiley's. If I had a bunch of clones to add up. All right. Getting tired if you can't tell. It's been a long week. So I'm sure it has been for you guys too, though. So we'll keep going. It's what you do when you're tired and you've had a long week. You just keep going. You do it even better. So we have 6x plus 3 times the quantity, the sum of 2x plus 1. So probably the first thing you're going to want to do here is distribute this this 3 through. So 3 times 2x, 3 times 1. And then we have, so this is all going to be equal to, we're not doing anything with 6x, so just write it in. Now we're doing plus 3 times 2x, the red arrow. 3 times 2x would be 6x. Plus 3 times 1 with the blue arrow, which would be 3. Now you add these up. Now 3 doesn't have an x with it, so we can't add this to the terms with an x in it. So we do 6 plus 6, 12x, and then we just leave the 3 to the side because there's no x, there's no y, a, b, c, d, whatever. So this is your answer, 12x plus 3. Alright, so now this one's a little more challenging. So, but it's the same steps. Negative 2 times 2x, negative 2 times 4. So this is going to give us negative 2 times 2x will be negative 4x. Negative 2 times 4 would be negative 8. So I'm going to do minus 8. Right, because subtraction is really the same thing as adding a negative. And we add 4x. And then we add 8. And you can see the little thing I like to do is show you how these messy looking problems a lot of times can just end up being 0. And that's what you'll see here because we have the x's are going to cancel out. Negative 4 plus positive 4x. Oh, negative 4 plus 4 is 0. So we have 0. And we have minus 8 plus 8. Or switch them around. 8 minus 8. That's 0. So 0 plus 0. Oh, that's still 0. So when in doubt, if you ever have no idea on a question, a lot of times it can be good to guess 0. But it's not always going to work, but maybe. But maybe sometimes it could help. Fill in the blank to make the expressions equivalent. So this is kind of a factoring question, but you don't necessarily, if you didn't understand factoring, you can think about it with the distributive property as well. Okay. So each side is the same. So we're trying to balance it out. What do we need to put here in the blank so that these are balanced? Well, notice that the only difference here is that there's this 8 in each term. So if you think about it, if we were distributing an 8 through, well, we'd have 8 times 4, which is what we get here, and then we'd have 8 times 1, which is what we get here. So the answer has to be 8. Okay, so this one's a little trickier. So now I want you to think about, okay, we have x plus 3 here, and I have a 6x plus 18 on the left. Well, to turn an x into a 6x, well, I know I'd have to multiply it. Right? 6 times x. That would give me 6x. But then we also have an 18. So I have a 3 here. Well, let's try this out. If I do 6 times 3, oh, that gives me 18 as well. So this seems to check out. That means that filling in 6 would be the correct answer. Okay, let's look at this one. Let me. Yeah, I'll just get 2. It's going to go for 3, but I think this will be more time efficient. Okay, so now in this case, we have a 14x here, and we have a 2x here. Well, what would we have to multiply 2x by to get 14x? Or you could think about 14 divided by 2, 7. Yeah, so if I do 7 times 2x, oh, that'll give me 14x. But then, what about the next term? Let's see, we have a 7 over here. If I do 7 times 1, that should work. As you know, 7 times 1 is 7, so this seems to check out. Plugging in 7 here seemed to work. Alright, so over here, it's a little different, but same idea. Notice we have a 9 outside, so that 9 times x would give us 9x. That's good. And then we have 9 times this number will give us 36. So you can think about what times 9 is 36, or you can do 36 divided by 9. That tells us 4. And then you can just double check it. 9 times x plus 9 times 4, 36. 9x plus 36. Alright, so we're getting to the home stretch here. So this one was a little trickier because there's negatives. So we need to find out what goes here. So to do that, well, you can just distribute this negative 24 times the negative 2. Negative 24 times negative 2, that's positive 48. If you double check it, 48x plus 24, well, let's see, we'd have negative 24 times negative 2, that's a positive 48. Negative 24 times negative 1, it'd be a positive 24. So that works. Which expression is equivalent to the following? So we have different expressions down here. There's only one correct answer. So when in doubt, just go ahead and start expanding. So whenever you're in doubt in algebra, just start expanding or simplifying. And a lot of times that'll get you closer to where you need to go. So we have 5 times 5v. 5 times 5 is 25. So we have 25v. And then we have 5 times 5. So plus 25. And then we have another 3v over here. So I'll keep that in red. Because these are both like terms. 25v plus 3v would be 28v. And then we have the plus 25 left over. Because there's no letter next to it. So it's can't combine it together with a number that has a letter next to it. So 28v plus 25. This answer down here. Alright, so last 3 questions here. Is 3 a factor of the following equation? Just you have to see, does each term, each coefficient, does that divide by 3? I guess really, does each term divide by 3? So 24 divided by 3 is 8. So we know that works. But 16 divided by 3, I mean, you can do it, but it's not going to give you a whole answer. So if it's not a whole number, we say it is not a factor. Is 12 a factor of the following equation? Hopefully this one was easy. If you knew factor, it should have been. Do each of these divide by 12? 12x divided by 12. It's just x. 120. So yeah, I should have put a Q up here. So we do 120 divided by 12 gives you 10. So it is a factor, right? Because we could do 12, because then we could factor out the 12, and that would leave us with x plus 10 left over inside. Yep, so this last question, I probably won't put this on the test, but I'm asking, is 12 the greatest common factor of the following equation? So is this the biggest factor that 12x and 120 have in common? Is 12 that biggest factor? And it turns out it is, and we know this actually because if you can't divide 12x by a number bigger than 12, otherwise you're going to get a decimal, and so it wouldn't be a factor then. So it was a factor, and it's the biggest it can get, so it must be the greatest common factor. All right, so that's all I have for you today. Hopefully you found this helpful and worthwhile. Sorry the video is long, but if it makes you feel better, it is shorter than 7th and 6th graders videos. So there's that. But yeah, in general though, if you've been doing all the work, just take a deep breath and relax. If things don't go well with the test and people struggle, I'm open to something like a retake. So in fact, I might even mention something about that tomorrow. So just please just try your best. And trust me, if you've been doing the work, know that I know that. And I will do what I can to help you out. I'm not going to give out A's, but I'm going to work with you. So that's all I have. Please take care, guys. I'll have another video for you guys tomorrow just to give you instructions. But I'll talk to you then. So take care.